Hey there, welcome to the channel. We will explore the importance of materials science in tackling sustainability issues on our planet. Have you ever stopped to think about where all your takeout containers end up? Or wondered if that plastic bottle you just tossed somewhere will be around there and for how long? Well, you are not alone. Plastic takes hundreds of years to break down. Today, we will be diving into the world of sustainable packaging. We will explore how materials science is taking on the big bad wolf of our time, plastic waste and plastic pollution. Let's get started with a quick reality check. Every year, we produce about 350 million tons of plastic waste. That is roughly the weight of the entire human population. Pretty mind-boggling, right? We still need traditional plastic-like materials. But here is the good news: scientists and engineers are working hard to find solutions. That is where biodegradable plastics come in. These are designed to break down more quickly than conventional plastics, and bioplastics, once broken down, will not leave residues of microplastics like traditional petroleum-based plastic. With the knowledge and help of materials science, scientists and researchers are developing new materials. The new materials are meant to replace traditional plastics and solve the plastic crises. Technology, data-driven decision-making underscore the fact that we must continue to evolve. We must learn, become literate and apply renewable materials in achieving a sustainable future. These alternatives should be designed to break down naturally without harming the environment. First up, let us talk about bioplastics. These are plastics made from renewable sources like cornstarch, hence called bioplastics. Bioplastics are materials made from plants and biological sources instead of petroleum. Unlike traditional plastics, bioplastics can decompose under the right conditions. One popular type is PLA, or polylactic acid. PLA is derived from sources such as vegetable starches, sugarcane, food waste, and lobster shells. It looks and feels like regular plastic, but it is made from fermented plant starch. PLA is already being used for things like food packaging and disposable cutlery. PLA are the most common bioplastic used to make single-use items. Examples of PLA uses are takeout containers, straws, cutlery, compost bags, and water bottles. One promising option is PHAs, or polyhydroxyalkanoates. Polyhydroxyalkanoates, or PHAs, are bioplastics engineered from microorganisms. These are produced by bacteria and can decompose in soil and marine environments. Material is produced through fermentation of sugar or liquids. PHAs are often used in medical devices such as sutures, and newer applications are on the rise. But bioplastics are not perfect. They often need specific conditions to break down properly. That is where compostable materials come in. These are designed to decompose in home compost bins or industrial composting facilities. One exciting example is a material made from mycelium, the root structure of mushrooms. Companies are using mycelium to create packaging. Mycelium-based bioplastic is sturdy enough to protect products during shipping. And when you are done with it, you can toss it in your compost bin and watch it disappear. Now, let us shift gears to edible packaging. Yes, packaging you can eat. Scientists are developing films and coatings made from natural ingredients. Examples are milk proteins, seaweed, and fruit pulp. Imagine buying an ice cream cone wrapped in a flavored, edible film. No waste, and maybe even an extra treat. Of course, creating new materials from renewables is only part of the solution. We also need to rethink how we use and dispose of packaging. That is why some companies are exploring reusable packaging systems. Picture this: you order takeout, but instead of getting disposable containers, your food comes in durable, reusable boxes. After you are done, you return the containers to be cleaned and used again. Another approach is minimalist packaging. This involves reducing the amount of material used to package products. For example, some companies are now selling shampoo and conditioner in solid bar form. It is an excellent innovative manner of eliminating the need for plastic bottles entirely. Now, you might be wondering, what about recycling? While recycling is important, it's not a perfect solution. Many types of plastic are difficult or impossible to recycle. That is why scientists are working on new recycling technologies. One exciting development is chemical recycling. This process breaks plastics down into their basic chemical components. These can then be used to create new plastics, potentially closing the loop on plastic waste. But developing new materials and technologies is only part of the battle. We also need to change our habits and expectations as consumers. This means being willing to try new types of packaging. We should be open to even if packagings look or feel different from what we are used to. It also means being more mindful about how we use and dispose of packaging in our daily lives. So there you have it, the world of sustainable packaging is full of innovation and creativity. From mushroom-based shipping materials to edible wrappers to newer pulp-based materials. The future could look a lot less plastic. But remember, the most sustainable package is the one we don't use at all. So next time you're shopping, consider how you can reduce your packaging use. Every small action counts in the fight against plastic pollution. If you found this video helpful, please give it a thumbs up and share it with your friends. And don't forget to subscribe for more videos on sustainable materials. Thanks for watching.